We are in Precalculus today on November 30th. 30th, I cannot pronounce that. That means it's Mr. Sindell's birthday.
Happy birthday!
Yay, thank you. All right, so let's talk about some addition and subtraction of
Wait, are you a Sag? You know what's funny?
Yes.
Your birthday's the same day as Mr. Krabs.
I did not know that. Okay, cool. I didn't know that they had birthdays in SpongeBob.
He's 76 years old today.
Wow, all right. Is that just the first date that he aired, or does he actually have a birthday that's in the fiction?
I guess like he shows his ID to some like in one of the episodes, and it has like 11:11. I mean 11:30 and 46.
Oh wow, okay. Yeah, he's old. The creator of SpongeBob, the original writer, wasn't he like a marine biologist or something like that?
Yeah, and he passed away like 50.
Yeah, sad.
He was 56 or 57.
That's kind of young, huh? All right, well, let's talk about some vector addition. So if I have vector u, vector w, and I want to add or subtract them, essentially what you need to do is you need to take the x component of the u, add it with the x component of the w. If you have the y component of the u, add it with the y component of the w. And I mean, that is a very complex formula. It confuses us. It looks like Chinese. Let's go ahead and just say this. In simplified English, you just add or subtract x is x, x with x, and y with y. Add the like terms, essentially. So let's see an example of how to do this. It's pretty straightforward. I think Rochelle and Daisy can probably do this if you didn't even have the notes today. So if you have u is equal to 13 and negative 2, w is equal to 8, negative 4, let's add them together. So add the components. 13 plus 8 is, Rochelle?
13 plus 8?
Yep.
That would be 21.
21. So that's the x component. Add the y's, Daisy.
6.
Careful.
Oh, wait, 2.
Careful.
Wait, what? Negative 6.
There it is. Negative 6.
There we go. I didn't even see the negatives up there.
You're good. Yeah, so that's how you add components. Let's just try another one where we subtract them. This one is a little bit tricky. It might be worthwhile writing out what happens, so I'm going to write it out. Whenever you have a negative, it does get a little bit tricky. So I'm starting with w, not with u. So I'm starting with 5. So 5, and then the x component is negative 9, but I have to subtract negative 9, so it's minus negative 9. And then the y component, I start with w, I start with negative 3, and then I go to u, minus the negative 4, minus negative 4. And that simplifies to what? Daisy, you want to do the first part? Rochelle does the second part? All right, Daisy, do the x component. Positive or negative? Positive. Okay, Rochelle?
It is going to be 1.
Positive or negative?
Positive.
Yep, nice. All right, there it is. All right, so that's the easy peasy part. Graphically, they can be pretty tricky. And by the way, tonight we have 2 things for homework. And the first part was doing all this, which is pretty straightforward. And the second part can be tricky. It's doing all this graphically. All right, so when I have vector u and w, and I want to add them, essentially what you need to do is you need to move v onto u or move u onto v. The way that you do this is called the tail to tip method, which means, so the tail of the arrow looks like this. So you can think of the feathers down there. So if I have the tail of the arrow down here, that tail goes to the tip, which means that this u gets moved here. So notice that you went right 1, up 4. Right 1, up 1, 2, 3, 4, which means I moved that arrow. It's not that. Wait, I have technology. What am I doing, Mr. Snell? Just go like this. I have an arrow. It goes like that. I can move it like that. Alternatively, I could go like this. I could move v to u. If I move v to u, notice that v goes right 2, up 1, right 2, up 1, which means I could have this v moved here. Either way, the resultant vector of adding means that you draw the final vector from the first tail to the second tip. So here you go. And I need both of your eyes before I do this because it's really important. That means that I'm going from here to here. That's my final vector. I'm going from here to here. That's my final vector. Notice that both of these yellow vectors are the same vector. They go right 3, up 5. Right 3, up 5. Just want to count to make sure I'm saying the correct information. That's the tail to tip method. How's it going?
Well, I did not enough for the SAT, but I can do it after.
Okay.
Can I just say, I was actually doing this for the practice SAT.
This stuff right here?
Yeah, this lesson.
Oh, wow, nice. Well, now you're definitely knowing what's going on. All right, so you're still confused on what we just did here?
Yeah, that's what I was trying to understand. I was like, okay. I get it.
You're okay now? Okay. I want to move this one. Can I move this one slightly over and up? Okay, good enough. All right, what if I want to subtract? So let's say I want to subtract v. If I want to subtract v, first I need to make v negative. If I want to subtract v, this v right now is positive. To make it negative, I need it to come down like this. It's a straight line. Notice that it's 180 degrees. It's a straight line, but now it's going in the opposite direction. It used to go right 2, now it goes left 2. It used to go up 1, now it goes down 1. Each of the components is now negative. So this is a little bit harder when I subtract. First, make it negative, and then do the same procedure, tail to tip. So then I basically copy this with technology, paste that vector, and then move, come on vector, I just want to grab you and move the tail of it to the tip of u, and the resultant vector is u minus v. I'll go ahead and do that in yellow again. I'll do u minus v. This vector right here that we just found is u minus v. Are you okay with how to subtract graphically? Okay, so when adding, what is that method called? Put vectors, tail, to tip, yep. And then when subtracting, what's the first thing that you have to do? What was that first step that we did?
Oh, you're supposed to get the opposite.
Opposite, yeah?
Oh!
Is there another way of saying it, Daisy?
Sorry. I'm so sorry.
Is there another way of saying that? How would you say that, Daisy?
I don't even know.
How would you say that we flip it?
Flip it?
Okay. You could say rotated 180 degrees from the tail. You could say reflected across some weird line. There's a bunch of ways you could probably say this. Which one do you want to put in the notes? What would make the most sense? This is your notes.
Reflect.
Reflect. I think reflect might be actually the hardest one because if you want it to be reflect, then you can have it reflect. It is your notes. So reflect. And then the note here should make a straight line.
Can I just point out, as you're no, we were supposed to, wait, are you still taking that? No, I'm not.
Yeah, we planned to have SAT work built into the schedule. Was it, what happened? Was it that less?
It was this week. We were supposed to do it, but you were gone.
It was last
Oh.
week. I mean,
No, it was this week.
I'm sorry. Sickness, man. And I guess, yeah. I apologize. Example 3. Which vector equation matches the vector operation shown below in the diagram below? Or shown in the diagram below. Can't read. This is an exact problem from Khan Academy. So the way that you want to solve each of these is to look where the tail and tip matches up. Which one is tail to tip? Is it A and C, A and B, B and C? Which two vectors are tail to tip? C and B. Daisy, do you see it? Which two vectors are tail to tip out of these three vectors? C and B, yeah. C, then B. So this is saying C plus B is equal to A. That's what's being said here. This C plus this B, since they are tail to tip, they should be equal to A. And A does go from the tail to the tip as well. So is there anything in here that says C plus B equals A? It's literally exactly what you see for answer B. Let's try a harder one. Let's flip to the back. For some reason, I have this label. I have all these labeled example 3 over and over again. That is definitely a typo. This should be example 4, and this should be example 5. This is what happens when you wake up at 3 in the morning to try to make notes. All right, so which vector equation matches the vector operation shown in the diagram below? Okay, look for 2 vectors that are tail to tip.
Ooh, there's not. What?
There's actually
I mean, all of them.
all of them, yeah.
Something else.
So I could say A plus C is equal to, oh wait, that's not quite the case. Look, so if A plus C, if A and C were tail to tip, that would mean that B should be going this direction, right? Because it starts here, goes here, and then ends here. But it's not, it's going the wrong way. So that means what's really happening here is that A plus C is equal to negative B because it's going the wrong way. Is there anything over here that says A plus C is equal to negative B?
No.
No? Okay, let's try another one. Let's try C plus B. It looks like a lot of these are C plus B's. If I do C plus B, that means I'm starting here. I go this way, then go this way. I should end here, which means A should be facing this way, but it's not, which means it should be a negative A. Do any of these say a negative A? Daisy, do you see it?
Wait, what?
Okay, let me repeat that. So I'm starting here. I'm going along vector C. I'm saying C plus B. Starting here, coming along here, coming along here. I end at this spot. This was the start. This was the end. That means that vector A should be pointing this direction. Do you agree? Because that was the start and that was the end. But what do you see vector A doing? Vector A is pointing the wrong direction, right? Which means we need to make A negative. So we need to somehow say C plus B is equal to negative A. Is that one of our answers over here? Yep, it is A. And our final example, example number 5, which of the diagrams describes a valid way of obtaining U plus V? Again, you're just doing this tail to tip. It's either one of these, both of them, or neither of them. Okay, well, let's analyze choice A. Why is it not A?
Because it's a negative B, so it would have been A. I mean, it would have been U plus negative B, but that's not the case that you're trying to obtain.
U plus V, yeah. So there's a random negative V in there. So it's obviously not that one. What about this one? Does this look okay? What do you think, Daisy? What about B?
Still a little confused on this. On this stuff. Sorry. Well, I mean, I don't think it goes with the field, right? Because like, if you're supposed to reflect the vector V, I mean, the other side, what makes sense, right?
So you're only reflecting it if you're subtracting. Right now we're just adding.
Subtracting? Oh, it's an addition.
Adding just means we're just putting it tail to tip. That's coming from that first star right here. When adding, just put the vector's tail to tip.
A would have made sense if it was saying U minus V, would it?
Yes.
Oh, yeah.
So talk to me about
So it's
this one then.
So it's telling you to start from U up to V, right?
So
U plus V,
we start with U.
and then you go down to V.
We go down here. We put V at the tip of U. So the tail of V went to the tip of U, which is what we're supposed to be doing. Does that look like both those vectors are still the same? What are our thoughts then?
I think it's B.
You think it's B, Daisy? It is, yeah. That's our answer. Done. Let's work on Khan Academy Day. I'll help you out as you're working on that. Go ahead and write your summaries, please.